Hi everyone, I'm Ryan, and today I'm going to be demonstrating some electrical experiments. So first of all, all of us already know that electricity is the flow of electrons, and the flow of electrons causes current. Now let's put this into action. So as you see, I have this circuit right here. I have this battery. This is the electrical symbol for battery, and we have this switch, and that's the symbol for switch because once we push it, it allows the wire to flow, which enables the circuit. So we have this switch, and we have a resistor, which is labeled R in electrical physics, and this is basically the resistor for the whole circuit. Now, if you're beginning to just use breadboards and connect circuits and stuff, I'd recommend adding more than one resistor, because resistors resist the flow of electrons, so you don't want it to overheat. So we have our resistors. This is the resistor for the whole circuit. We only need one for our purposes because we're only using 3 devices that essentially behave as a resistor. Then we have this diode, which forms one path of electrical current. This diode is a light-emitting diode, in other words LED, and it's important that we have this resistor to reduce the LED's light, because LEDs don't need much electricity. And then we arrange this in parallel, because if we arrange it in series, if we arrange 2 light bulbs in series, it appears dimmer than if we did it in parallel. Because in series, there's less current flowing. As you can see, there's so much current flowing. This is why we arranged it in parallel, or else it wouldn't work. And then we have this motor, which is labeled as M, which forms our second type of current, and our third type of current is a fan. Now let's see this all in action. So we have this battery, and we connected to these 2 sides. So this is the terminal. This part is the positive terminal, otherwise known as the terminal, and this is the negative terminal. So if we connect these 2 to here, the electrons flow from here to there from this black wire, and they go to this button, which then transfers to this yellow wire and goes to the negative part of the motor, the negative part of this fan, because this fan, the green wire of the fan is the negative for this fan. And as you can see, we didn't have enough space to put the LED, so you simply just added the blue wire to connect the negative leg of the LED simply right to here. So now all of the electrons are going into these 3 devices: the motor, the LED, and this fan. The fan's right here. Anyways, so then we have that, and then we put this to a resistor. As you can see on our circuit, we added a resistor because we wanted to reduce the electron flow. So then we put it right here, and then we connected to this one to the terminal. So the terminal is connected to this place here, which is then connected to here. And basically, this is a circuit because, as you notice, it keeps looping around. It goes from here to here to here, and then back. So if we put this into action by activating it, as you could see, I put this here. If I click the button, all of it activates. The fan activates, the LED activates, and this motor activates. So if I try that again, if I hold this up this time so that we could clearly see, now I just want to say that when you're using these types of experiments, you need to know how much is the voltage. If we just want to use the fan, then we need to have a 12-volt battery. This is a 9-volt, but for our purposes, it's enough. That has been it for, thank you for watching this, and that has been it for the experiment.